Welcome back. Today we're going to go over another section in chapter 21. Actually, this isn't in chapter 21, is it? All right, so this bit is a introduction, exposure to some ideas of histograms, some of the different types that there are. We did histograms in the last section, which is sort of like a modified bar chart that is a graphical representation of your data. But today we're going to talk about some specific types of histograms from what's known as a bell shape to my favorite, which is the dog food. So our goals for this particular presentation are actually quite simple. There's really only 3 of them. We want you to be able to identify different types of histogram distributions. We want you to familiarize yourself with the different characteristics of a histogram. Totally spelled that wrong in the presentation. And then the third one is just that I want to expose you to some of the terminology, and I want to use some of it myself so that you get used to hearing it and seeing it. All right, so the first type of histogram that we're going to talk about is what's known as a bell curve or a normal curve. This is the one that we're going to study more in depth in this course, but just to give you a quick overview, the bell or normal curve is a very common pattern. In this particular distribution, data points are just as likely to occur above the average as they are to occur below the average. There's some symmetry here. There can be a lot of distributions that look very similar to normal, so we will say it looks normal, but in order to award a histogram the name of normal, there are actual mathematical calculations that have to be carried out. So that's, again, a little bit more into statistics than we're going to go. Just know that we can say it looks like a normal curve or it has a bell shape to it, but we cannot flat out call it a normal curve until we've done some more in-depth calculations. All right, so what makes this normal curve this sort of bell shape? First of all, it has a definite peak, and that peak is in the center. Specifically, that peak occurs at the average or the mean for the data. The left side and the right side of this particular bell-shaped or normal curve look symmetrical. They don't have to be perfect, but they've got to make a rough image, like a rough mirror image of each other, okay? So that's the main type, and that's the one we're going to study. The next one is what's known as a skewed histogram, and a skewed distribution or a skewed histogram is not symmetrical. It either tends to lean way over to the left or way over to the right. The trailing edge is called a tail. So the edge that's lower is called a tail. The tail is what names the skew. So for example, the one on your left side in this presentation, let me get my pen. This one, pen. This is actually known as a right skewed because the name of the skew, right skewed, is based on the tail, right? Because the tail is right here. That means the other one would be our left skewed because our tail is on the left. Now, these right and left skewed histograms generally happen when you're analyzing something like when do people get their driver's license. So we know that that's going to have a peak around 16, and then it's going to have a right skew as people get older. Fewer and fewer people need their driver's license because, well, they've already got it. Some of the things that might be left skewed are, I don't know, maybe it's people who came down with type 2 diabetes, and type 2 diabetes happens when you're older generally. It's sort of something that occurs after middle age, so after 50s. So this would be more of a left skewed diagnosis, as you wouldn't diagnose usually a 14-year-old with type 2 diabetes. So this is where left skewed and right skewed come into play. And they show definite bias for different age, maybe a weight, could be a height, anything that could be measured with some consistency. The next one, let's see if we can get here. The next one is what's known as a bimodal. This one has 2 humps in it. We know that bimodal means that there are 2 modes, and basically what happens is the histogram demonstrates this. So the histogram tends to cluster or group the data around each of those 2 modes. That's why we call it a camel. There's not really a whole lot to say here. The example is that if you've got a 2-shift operation, the peak production might be bimodal. You might have your peak production at 8 o'clock at night, and you might have a peak production at 11 o'clock in the morning because you've got 2 different shifts working. All right, next is what's known as a plateau, sometimes called a multimodal. It just basically means that your data is fairly consistent. There's not a whole lot of difference between the classes, the frequencies in any of the classes. So one frequency might be 8, and then the next one is 6, and then it's 7, and then it's 9, and then it's 5, and they all sort of hover around the same sort of frequency number for each of the classes. This one is known as an edge peak. This one will occur when you have data that is sort of, well, everything's sort of nice and listed, and then all of a sudden it's less than or greater than, or before or after. So let's say we were doing an archaeological dig and we had stuff from the last 1,000 years, the last 2,000 years. So we went from the year 1000 to 1999, and we went from 2000 to 2999. And then we've gone from 0 to 999. But anything before 0, like anything BC, was just before BC. We just did before. And so all kinds of data would be on that, and that would cause a peak right there at the edge of the data. It would cause us to spike because all of a sudden we're ignoring classes again. All right, not last. So we've got a comb. A comb distribution alternates between tall and short, tall and short. I like that it's sort of an indication of a histogram that was constructed incorrectly, or at least might be calculated incorrectly. This is sometimes happens when we use less than or greater than functions in math. Again, not necessarily something we need to go into. Just know if you ever see this type of histogram that there could be a problem with your data set or with the way that you have constructed the histogram. All right, the next 2 are my favorite. So this one is what's known as the heart cut. This basically looks like a bell shape, but we've cut off the edges. This type of histogram will usually happen in some sort of manufacturing plant or possibly a distribution plant where there are requirements for weight or length or size, and they are specific so that the ones that don't meet that requirement would be cut off. In other words, to give you a practical example, I love Frosted Flakes. And when you buy a box of Frosted Flakes, it says that there are like 23 ounces on the box. Well, the fact is there's not 23 exactly on every box. Usually there's a range, and they say, okay, if it's 22.2, we'll let it in, and if it's 23.8, we'll let it in. So there's like a range. So we're really going to go from 23 22.2 to 23.8. And anything that's less than that, we have to like send back, and anything that's more than that, we have to send back. And so giving those specifications, giving that range is what will cause the heart shape. Okay? Likewise, when they do that, then anything that's dropped off, anything that's below the 22.2 and anything that's above the 23.8 gets, I don't want to say destroyed, but it can't be used. Those boxes aren't sent out because they're too light or too heavy. And so those boxes, that discarded material, would cause what's known as a dog food. I love the name. It's called the dog food histogram, basically because, well, not because the heart is cut out, which I suppose you could say it that way, but because the image that's left is that of a dog bowl. Right? We took the center out and left it empty, and we end up with something that looks a lot like a dog bowl. All right. Now, that's the sort of, what did I have, like 8? I think there's like 8 different histograms that it was kind of nice to spend 10-ish minutes talking about. Is there practice for this? I did find some practice online. You can use the link there, the McDowell Statistics, Weebly.com. It's just a real sort of quick, I guess it's a PDF, and then the answers are at the bottom. So you don't have to like print it out or anything, but you could like go through it if you were sort of interested in checking to see that you know what some of the different distributions are. There is not graded homework on this. So there's no graded homework with this presentation. Yay! All right. Thank you. If you have any questions, don't hesitate to contact your instructor, your math support personnel, or the Math Center. Thanks.